Hey, Algebra 1, Catlin here with your help for your cool down on this rocket problem. We've got the height h of a stomp rocket propelled by a short blast of air. I've seen these before where there's um, like a circular thing that you stomp on, and then that pushes air up into the bottom of a rocket and shoots it in the air. It shoots it up above the ground after t seconds. So time is passing, h is height, and we're given the height of this equation by this quadratic. H of t equals 5 plus 100t minus 16t squared. And here's a graph that represents it. So you can see as the time passes, the rocket rises and the rocket falls. And what we want to do here is we want to explain what some of these parts of the equation mean. So let's start with copying it down. We've got h of t equals 5 plus 100t minus 16t squared. All right. So, how does the 5 in the equation relate to the graph? Well, the 5 is right here. Okay. The 5 is the starting height of the rocket. So, the rocket must be sitting up on a little bit of a pedestal that's 5 feet up off the ground. So, 5 represents the starting height of the rocket. All right. So, we got that down. Now, number 2, it says to tell what 100t in the equation is representing. Well, we know that the negative 16t squared, based on our discussions in class today, represents gravity's effect on a falling object. But the t term comes from the speed in which the rocket is taking off at. All right, so 100t represents the initial velocity that rocket is traveling. So this is the speed in which it comes out of the stomp. So the air that pushes it up, that's how fast it's moving right at the beginning. And then, like I just talked about, the negative 16t squared is representing the effect of gravity. So this is the negative pull of gravity on the rocket. Okay, that's what the negative 16t squared represents, and that's quadratic. About when does the rocket hit the ground? Well, the rocket reaches its highest point right here at about 3 seconds, a little over 150 feet. But it hits the ground back when it cuts across the y-axis. It looks about maybe 6.25 seconds. I would say about 6.25 seconds would be my guess. And whenever it comes back down to the ground and hits the surface. So peak, starting point, launch, land. And that's how these upside down parabolas can model the projectile flying through an air from a launch point with a given initial speed. Later, guys.